Well, hello everybody. So I'm going to just go with you through very simple steps how to use RimPro's apple scab prediction model. This is the interface webpage where you can access RimPro. It's rimpro.eu, and then when you are there, you use your username and password, type in and log in. Okay. So when you log in, it's going to be pretty simple to use RimPro. So we're going to just go through some simple steps. How do you really interpret your model? So you go to the station to open your location. So you click on, in this case, I'm going to use Highland Nua. Then you go to the model, and then you go to the apple and pear scab. And then you're going to get a scab graph like this that is called scab primary. That means actually the infections that are happening from the primary or the ascospores, basically the spores that have been produced by sexual reproduction. So the graph shows you the blue line here, which is your current time within the day. And on the left side here you see the historical data collected from your rain-wise station. And then this is your weather forecast. And in this specific case, the weather forecast is from the Norwegian model called year and number. And what we see on this specific day, which is today, is the 16th April 2018. We see basically that there's this white hump here, and then at the bottom of the white hump we see some red lines here. So we're going to go through and explain what does that mean. If you look at closely here, if you zoom on this white hump, which is basically a prediction, you'll see small yellow bars. And those yellow bars basically are interpreted as the ascospore release number per hour. And if you want to really know how many ascospores are being released per hour, these yellow bars go, one right after another. You can actually use this this y-axis here on the right side, which gives you a discharge number of ascospores for these small yellow bars. But then what does this white hump mean here? Well, it means that this is a cumulative number through this amount of time here, cumulative number of the ascospores that germinate from this number of released ascospores. And germination by itself does not mean that you're going to get infection. So we're going to go in a second and show you how does the infection period looks like. So at the bottom of this white hump you see this red line. So what does this red line actually represent? To better show you that, I'm going to switch now and show you how the real infection period looks like. So you see this white hump here, you see your basically cumulative number of ascospores that were released and they are germinating. But then you see this red line here that basically is a consistent curve of small dots, and those are so-called rim values. So the rim value basically is red on the left side y-axis here, and the red line is actually, in a simple terms, representing infection value. So what it does actually, it shows you a percentage of the total seasonal number of ascospores that are likely to cause infection in any given event such as this, and it's multiplied by 100. So if we were able to go and see the top of this hump here, you can basically see that if we have a rim value or this red line value of 1000, you can interpret it actually as 10% of the seasonal 10,000 ascospores being able to actually form an infection. That's what this red line shows you. And what this orange color behind shows you, we call it primary stroma. That basically represents the scab lesions that are basically initiated by the infection of these ascospores here. And they're incubating, they're basically towards the process of leading towards formation of lesions or symptoms at the end of the infection period. So basically what really has to interest you is this red line. Does this red line cross over certain thresholds or not? So let's just go and look at back the thresholds. So if we look at this graph, you'll see these dashed lines here, which shows you the medium infection risk, which is about 100 rim value, then you see a dashed line at the 300 infection rim values and extreme infection risk above 600 rim values. So that's basically giving you a visual, to what is it that you should be efficient for in this case. For most of the orchards that have been cleaned from scab last year, we do not consider a high infection event when the red line here, okay, does not cross over 300. So if it's below 300 for clean apple scab orchards, you don't have to really spray, because the apple scab infection or dose, apple scab ascospore dose is very low. However, in the orchards that had scab last year, and it showed up anytime, either on the leaves, very little, as secondary scab, or on fruit, very small percentage, then we would call the 100 as a cutoff point. And if your red line actually crosses over 100, or the medium infection risk, we would call that as a warrant to spray in the orchard that had scab last year. So far that's very simple. So you can see here on this day of 16th April 2018 that the red line is very, very flat here. It doesn't have orange showing up behind it, and this is even below the slight infection risk here, which is probably below somewhere around like 20-30 rim values, and it doesn't warrant a spray. Okay. So it's because even in the orchard that had scab last year, it doesn't warrant the spray, and because there's no conditions for apple scab to establish infection. So what else can you see on this graph that is really informative to you as well? So you can see here the biofix date of 29th March. The biofix date is basically the date that we actually determine based on the ascospores that we catch in the ascospore tower, vacuum tower in the lab. We take the leaf litter from last year in the orchard that had scab, and then we monitor if we can catch the spores in the vacuum tower after dipping the leaves in water. And then if we do catch them, then we adjust this date based on the fact whether the ascospores are available or not, or basically if they're mature. So, and then we determine that date. On the day when we catch the first ascospore, we call that date a biofix. And you can actually set that in your RimPro model by using certain local parameters. But this graph here, below the big one, shows you a dark red surface and a very thin here light red surface. So to just make it easier for you to look at that, I'm going to go and switch back to this graph. And you can see that the dark red is called immature spores or ascospores, and the light red is called mature ascospores. So basically the light red ones are the ones that are ready to shoot out, and they're going to be available whenever it rains, and they're going to shoot out and be released, and the cumulative release is going to be shown as the white hump. Whereas the dark red is still the immature ascospores that still need time to mature, and they're going to be maturing over time with the rain and with different warm periods. So it's very intuitive, and it gives you basically a proportion of the scab spores. So these two areas, the light red and dark red, are basically a proportion of these scab spores, mature or immature. And then below that graph, you can see a very simplified small line graph that shows you in dark blue the actual rain events, and they're lasting in hours. And then right after that, you can see the length also in hours of the wetting period, how long the leaves are going to stay wet after the rain. So you can see that as a historical data here, and you can see that here as a future, what's predicted. What we usually recommend is that the growers do not look past 96, actually ahead of 96 hours from the current date, and do not rely on the weather forecast after 96 hours, because weather forecast changes very frequently, so we only rely on the 4 days ahead from the current day to basically look at. It is nice and good to have a 10-day forecast like it is shown here. However, weather forecast can change fast, and we only use the weather forecast after, basically ahead of 96 hours, just for tentative purposes to see what is probably coming ahead for infections. What else is important for RimPro? It is very simple to use once you go through a couple of these steps, and it is straightforward, and it is really accurate in most of the cases, and different other labs, including University of Massachusetts, the Amherst lab is looking at the actual data from the field. They are actually comparing the ascospore release and captures of ascospores with whatever RimPro is showing, and also some people at Michigan State University are doing the same thing. So all of their preliminary data indicates to us that there is a lot of accurate information you can get from RimPro in terms of when to apply your spray and use your spray. So what is your strategy? How do you really approach spraying should you spray for an event like this, or should you spray for an event like this? So it's very clear and simple. In this case here, your spray is not warranted because the infection that is happening here is minimal, or there is no infection here. There's no orange field forming after this red line, and this red line is way below 50 rim values. Doesn't even warrant a spray in an orchard that had scab last year. But if you have a big hump like this, white hump here, and the red line above, in this case it's above 1,000, it's a fairly huge number of ascospores released and germinating. If you have this announced orange line behind, it shows you that the infections are going to incubate with this weather condition, with these weather conditions. Then the most safest thing to do is apply your contact fungicide before this event. Okay, be covered at this time here, and then go through your rain, and then apply your fungicide sometime after this big event, but apply a systemic fungicide together with a contact. And usually that spray that's going to happen after this infection, big infection event, should contain systemic to cover for whatever infections went through after your deposit from the contact fungicide that covered you was lost. So then you basically kill those infections by the kickback activity of some fungicides, and you get protection for the next infection period if it's closer to that time. We usually say that that time period is around 5 to 10 days between the sprays. It really depends on how much rain do you get and how good conditions do you have to apply your fungicide at the dry time. It is really essential to, in the last 5 years, we recommend not to rely strongly on a kickback activity by the systemic fungicides. However, use your fungicides wisely in terms of different modes of action. And what we usually recommend is early on in the season, after you're done with your copper, to rely on a Vanguard, for instance, or aniline-permitting fungicides that have up to 72 hours kickback activity, mixed always, of course, with your contact fungicide. And then after that, the weather is probably going to warm up. Then you can switch to something nicer like DMIs, such as Inspire Super, and different QOIs as well, and STHIs, so the newest class of fungicides. So we usually don't recommend more than 2 sprays per season of a certain chemical class, like an STHI or a QOI, 2 of those each per year. What is really important is that what RimPro does for you in this specific case, it gives you the ability to know when the infection is coming, to design your spray timing before or after very precisely, and allows you to actually avoid spraying for the events that are like this, that basically are not infection events. They're basically just ascospore release that does not bring to infection, and usually we have between 2 to 4 per season, at least in the Hudson Valley. We have usually 2 to 4 of these that really do not warrant infection. In this way, you can actually really apply the concept of IPM to combat apple scab as a disease that really is the biggest part of your bill for fungicides that actually come in for protection against this disease. So thank you for watching, and feel free to contact me anytime at the lab at 845-691-7231. And if you have any questions, don't hesitate to contact me or send me an email. Thanks.